Hello students. Today we are going to start our next chapter of class 8, that is Exponents and Power, chapter number 20, Exponents and Powers. In this period we are going to learn about part 1, that is Introduction to Exponents and Powers. Okay, so already we have learned some basic concept related with exponents and power. Okay, so now when a number can be written in exponential form, okay, and how it can be written, let us see. Okay, now suppose we have a number over here 2. Now here 2 is multiplied 1, 2, 3, 4, 5 times by itself. Okay, so instead of writing such a big multiplication, we can write it in a form. This form is known as exponential form, where this 2 is known as base and this 5 is known as power. Okay, now let us see why here, or what is the meaning of this 2 here and what is the meaning of this 5 here. This 2 indicates the number which is repeating itself. So here you can see that every time 2 is multiplying itself, so the number which is repeating itself is written at base, and how many times it is being multiplied. So it is multiplied 5 times. So we have written that 5 to the power. Okay. It can be read as 2 to the power 5 or 2 raised to 5. Okay. Now let us see another example. Now here 7 is multiplying itself. How many times? 3 times. Okay. So the number which is multiplying itself will be our base. And how many times it is multiplying? That will be our power. Okay. So how to read it? 7 to the power 3 or 7 raised to 3. Okay. Raised means it is written a little bit higher or above the base. Okay. Now here we have learned that if a number is repeating itself, it can be written in this exponential form. Let us see, if a number is already given in exponential form, what does it mean? How to write it in expanded form? Okay, so here it can be seen that a number is given at 8 raised to 5. What does it mean? That 8 is multiplying itself. How many times? 5 times. Okay, so it can be written as 8 into 8 into 8 into 8 and into 8. Okay, so I think this concept is clear to you people. Okay, now let us see some more things, okay, of these powers and exponents. Okay, remember one thing, that this power or exponent, they both mean the same thing. Okay, they both are same. Now in the previous class we have learned about some laws of exponents. If you remember, out of that law, today we are going to revise only one law, remaining we will see afterwards. Now here in this rule, it is given that if a upon b raised to any power m, then this power is both for the numerator also and for the denominator also. So it can be written as a raised to m upon b raised to n. Okay, so what is the law? If numerator and denominator together they have same power or only one power, so this power can be written separately for numerator in this way and for denominator in this way. Okay, now let us consider one example. Suppose if you are given with 3 upon 5 raised to 2. So what does it mean? That 3 upon 5 is multiplied how many times? 2 times. Okay, so this one is its expanded form, we can say. Now if you want to write this one with individual power, so this 2 is for 3 also and it is for 5 also, so we can write it in this way. Okay, as we have written it here. So what does it mean? That 3 upon 5 raised to 2 means this 2 is present for numerator also and it is a power also for denominator. Okay, now this we are going to use this rule, we are going to use further to solve some examples. Okay, and to get some new rules. Now let us move to the next part. Now in next topic we are going to learn about the sign, what sign we should write in answer. Every time we cannot multiply the sign, so one simple concept is that if suppose we have a negative number, now here minus 2 is a negative number. If the power of this negative number is an odd number, remember that this number is an odd number. Okay, so if the power of a number is odd number, okay, then our answer will always be negative. And now look at this number, we have minus 2 raised to 6. So 6 is an even number. So whenever the power of a negative number is even, our answer is always positive. Okay, just remember this rule. When the power of a negative number is odd, our answer is negative. And when the power of a negative number is even, our answer is positive. Okay, now let us move towards the next part, that is positive integral exponent of a rational number. That means that if the power is a positive number, then how to write it? Now, just now we have seen above that minus 2 upon 3 raised to 4. We have a number over here. So we have learned that this 4 is present for both numerator also and for denominator also. Suppose if you want to find the value of this one, so how will we write it? First, we will write this 4 individually for numerator and for denominator. Okay. Now, minus 2 raised to 4 means minus 2 is multiplied 4 times. Okay. Power is even number, so our answer will be positive. Okay. Then 2 is multiplied 4 times. So what will be the value? 2 2s are 4, 4 2s are 8, 8 2s are 16. Okay. Then next number we have 3 raised to 4. Now it is a positive number, means our answer will be positive. Okay. So 3 raised to 4 means 3 3s are 9, 9 3s are 27, 27 3s are 81. So what is our answer? 16 upon 81. Okay. Now let us move towards the next part, that is how to write a negative integral exponent of a rational number. Now, before learning negative integral exponent of a rational number, let us see what is multiplicative inverse. How to write a multiplicative inverse of any number. So, multiplicative inverse, or in other words, we can say it as reciprocal. Okay, so while writing multiplicative inverse, what we do, let us consider we have a number a. So multiplicative inverse of a will be its reciprocal. So 1 upon a. Now remember that here for this a there is no power. If there is no power, it means that the power is 1 over here. Okay. Now I want to write this a in numerator. Okay, I want to bring it to numerator. So whenever you are bringing a number which is present in denominator to numerator or numerator to denominator, its sign changes and the power remains same. Okay, so what is the condition there? The power, the sign of the power, it changes, number remains as it is. Okay, let us consider some example. Now here we have a number 2 raised to 5. Okay, I want to write this number with negative power. So what I will do, if I want to change its sign with negative power, I just have to take its reciprocal. Okay, so 2 raised to 5 can be written as 1 upon 2 raised to minus 5. Okay, now here in this example we have a negative power. We have 3 raised to minus 4, but I want to make it a positive power. So what I have to do, I just write here 1 upon 3 raised to 4. Why? Because if you want to change the sign of this power, okay, we have to write the reciprocal of this number. Okay, and the power remains as it is. Suppose if you have another example, if we have 1 upon 4 raised to minus 7. Now I want to write this number with positive power. So what I have to do, just will take the reciprocal. Now reciprocal means numerator goes to denominator and denominator comes to numerator. Okay, so what you will get here, 4 raised to 7. This is our answer. Okay, so now let us see. Now this one was only about a numerator number. Let us see what happens when we have a numerator denominator, that is a rational number or a fraction. Okay, now suppose if we have a number that is a upon b, which is in numerator denominator form. First, Let us see how we will write its multiplicative inverse or reciprocal. So multiplicative inverse of A upon B will be reciprocal, means numerator goes to denominator, denominator comes to numerator. Okay, so multiplicative inverse of A upon B will be B upon A. Okay, now this concept we are going to use further. Now suppose if we have a number that is A upon B raised to minus 9. Okay, so now here it is minus 9. Remember, first what we will do, since only one power is there, so this is present for both numerator and for denominator. So it can be written as A raised to minus 9, B raised to minus 9. Now I want to write this number with a positive power. So what I have to do, I have to bring it to denominator, that is its reciprocal. So after bringing to, or after taking its reciprocal, this A raised to A raised to n goes to denominator. Now here I have b raised to minus n. I want to write this one with positive power. So what I have to do? I'll bring it to numerator. So now what is our answer? B raised to n upon a raised to n. Again, both this numerator and denominator are having same sign. So what we will do? We can write it together as we have learned the laws of exponent. So what will be our answer? B upon a raised to n. Now we have to, what we have learned from this one. Okay, so we have seen that if we have a rational number with any power, if it is with negative power, and if we want to write it with a positive power, then what we are doing, so we are writing directly in this way. Okay, so what you will get, we are changing the position of the number, that is numerator goes to denominator, denominator comes to numerator in this way. Okay, and sign of the power, it changes. Okay, let us consider one example. Now suppose we have an example here, 2 upon 5 raised to minus 3. Now, instead of following this big procedure, directly I want to write this number with a positive power. So what I have to do, I will take reciprocal of this base. So what is the reciprocal of the base? So that will be 5 upon 2. Let us consider one more example. Now we have 3 upon 4 raised to minus 5. Okay, I want to write this number with positive power. If I want to change this sign, what I have to do? I have to take a reciprocal of the base. Okay, so what you will get now? 4 upon 3 raised to 5. Okay, let us consider one last example. That is, suppose if we have a number 2 upon 3 raised to minus 4. Now, I want to write this number, sorry, let it be plus 4. Okay, 2 upon 3 raised to 4. Now I want to write this number with negative power. So what I will do, I will just change the, I will take a reciprocal of the base. So 2 upon 3 will become 3 upon 2. And now this plus 4 will become minus 4 over here. Okay, so in this way we have learned about what powers and exponents, and then positive integral exponent and negative integral exponents of a rational number. Okay, so this much is enough for today. Thank you, have a nice day.